Okay, so I said free space propagation looks like this sphere. And I argued that the problem outside of free space is that you have various effects such as absorption, scattering, and whatnot that can destructively interfere and cause a higher path loss. So what are some of those effects? So signal propagation there are really four main effects of an attenuation. So there's attenuation. That's the expansion of the wavefront. And that's what gets you in free space. So even in the absence of anything else, attenuation will diminish the signal. The effects that can get you if you're not in free space, there are four main ones. We call them scattering, reflection, shadowing, shadowing, and diffraction. Interference is actually different. So these are effects that will get you even if you're the only radio in the world. Interference, what that is somebody else's radio affecting your signal. So right now we're just talking about the way one transmitter, the signal from one transmitter is propagating. So the best way to see these is by figure, and this will be figure 3 in your notes. So we've got scattering. Let's do reflection first. So that's where you have some very smooth, very well-defined, nice conducting wall. Your signal comes in like this and bounces off coherently like that. That's like a mirror, basically. Scattering is where you get a rough wall or something that's a rough wall as far as the radio wave is concerned. You get an incident wave like this, and it bounces off in all directions weakly like this. So the comparison there, if this wall here, or excuse me, if this chalkboard here were a mirror, that would be like reflection. Things would just bounce off coherently. But it's not. What you're seeing is the incoherent reflection of the light above. So it's scattering off in all directions, so you can't see the reflection. Shadowing, that's pretty obvious. That's where you've got a big building, and signals coming in like this. And you're sitting over here, and the building is absorbing or reflecting away from you. Doesn't matter what it's doing. But the point is the building is not allowing signals to pass through it, so if you're sitting behind the building, you won't see the signal. The last one you may remember from physics, it's called diffraction. That's where if you have some kind of point and a signal incident to that point, like so, just hits the top perfectly. You can consider the point here as a new source, so it'll start propagating as though that's a new source from the top of the point there. So if this were a mountain and there were a radio transmitter over here, you could be a little ways down the mountain and you would still get some signal due to the diffraction. So of these, that's going to the ones that we're going to talk about most today are reflection and scattering, because they contribute to a severe form of degradation in wireless channels called multipath fading. Okay, the last thing I want to say before I start talking about the mobile radio environment, which is our next major topic, I just want to say a couple words about antenna design.